Okay, right, here we go. You have to bear with me, this is a bit weird, this setup. I've bought like a tripod and stuff so I can video lessons, but it's particularly rubbish and keeps falling down. Anyway, bear with me. I'll explain this. Please email me if it still doesn't make sense afterwards. Okay, let's read the question carefully. So we have, I'll get my highlighter pen out, which is here. Two particles, A and B, of masses 6 kilograms and m kilograms respectively, are connected by a light inextensible string, so don't need to worry about the mass of the string, and it's not going to be stretchy. So as one particle moves, the other particle will also move. Particle B hangs directly below A, and a force, okay, that's important, particle B hangs directly below a force of 118 newtons is applied vertically upwards, causing the particles to accelerate at 2 meters per second squared. And that makes sense that they'll be moving at the same acceleration because they're connected, aren't they? So first thing I'm going to do is draw a diagram. All great question, all great answers start with a great diagram. So let's draw this one here. I have this particle and this particle. So let's call this one particle A. And we're told that this one here had a mass of 6 kilograms. So let's just write that on. Then I know that there is particle B. That has a mass of m kilograms. Right, and I'm told that they're connected by a light inextensible string. So let's have a look at that. That's my string. Okay, label the things that I also know on that. I'm told that it's moving up. So all of it is moving up with an acceleration of 2 meters per second squared. So 2 meters per second squared. And I'm told that a force of 118 newtons is applied vertically upwards. Well, that's what's causing it to move with an acceleration of 2 meters per second squared. So that's 118 newtons. Okay, I'm going to think about what my other forces are acting on this. So if this is a particle of 6 kilograms, it has to have a weight. So I'm going to label its weight. That's the mass, which is 6, times gravity, which is g. So that force is acting down is 6g. Then I've got another mass here, which is just called m. So therefore the weight of that I'm just going to call mg. I can fit that in. Right. Now, tension is going to act and it's going to cancel itself out for the whole system. That bit's a bit confusing. I'm going to call this T. That tension, if you think about it, because it's accelerating upwards, that tension is basically the thing that's pulling up this thing here. Yeah, or it's being pulled, the tension pulling down here is the mass of this, the weight of this thing. And then there's another tension here, which is essentially the force which is pulling up this particle B. Right. I don't know what the tension is and I don't know what the mass is. So there's two unknowns. There's lots of different ways that we can approach these things. I can either approach it looking at it at one particular particle, looking at the forces acting on one particular particle, or I can look at it as the whole system. Now, I'm going to have to look at it as the whole system for part A, because otherwise I'll have two unknowns. I'll have T and I'll have M, and I can't do that. So I'm going to look at it and I'm going to resolve it. So I'm going to resolve. So apologies for the handwriting. For whole system. Whole system. Right, and I'm going to resolve upwards. So let's think about the forces acting on the whole system. So if I treat this all as one. Okay, so the forces acting on the whole system are going to just look at the forces first. So there's this force here. There's going to be this force here, which is 118. So that one's going up, and I've said that up is positive. Then what forces are acting against it? Well, I've got, in total, the things that are going to be acting against it downwards are 6G and mg. So they're acting against it. I could, if I wanted to, put the t's in there as well, but if I think about it, they're going to cancel out, so there's not really much point in doing that. Okay, so this is essentially the total force. I know that force is equal to the total mass times the acceleration. So the mass in total, the mass is going to be 6 kilograms, because I'm looking at the whole system. I've got 6 kilograms plus m kilograms, mass, total mass, times the acceleration, which in this case is 2. Okay, well this is looking good, because all I have, the only unknown I have here is m basically. So if I then expanded this bracket, or 118 minus 6g minus mg equals basically 12 add 2m. Then let's just get all the m's on one side and everything else on the other. So I'll have 118 minus 12 is equal to 2m plus mg. Is that right? Oh, I've forgotten the 6g there, sorry. Let me do this again. 112, 118. So here we had 118 minus 6g minus 12. Let's see if I can use that. Yeah, okay. Now I want what this m is. So basically what I'm going to do is I'm going to factorize. So I'll leave that side. 118 minus 6g minus 12 equals m. Now I've got m on its own, that's great. Then 2 plus g. Divide both sides by 2 plus g. I'm going to have 118 minus 6g minus 12 all over 2 plus g is equal to the mass, which should have been, if we take g as 9.8, which we should be doing, you should have got that the answer was 4, I think it should have been. So the mass equals 4 kilograms. Okay, have a think about that. The thing that's going to be confusing is for part B, which I'll do in a moment, I'm not going to look at the whole system, yeah, because I want to work out what the tension is for part B. So just to recap what I've done, I've looked at the forces acting on the whole system. I've taken up as positive. This is essentially the resultant force, is equal to the total mass times the acceleration. That's basically what I've done here. So the resultant force is this. This is the total mass, mass, times acceleration. Then I've just singled out m and worked out what it is. Have a look through that, and then I'll do part B in a moment.